For decades, when we worried about space threats, we focused on the small stuff. Bus-sized asteroids, city-block comets, objects just big enough to scare us.
These were the objects we could see, track, and simulate with confidence.
They flashed bright, grew tails, and announced themselves clearly.
Over time, we learned how to predict their paths and risks. But here's a question worth asking. What if we focused on the wrong size?
What if the real story isn't about pebbles, but ancient mountains of ice?
That's where Bernardinelli-Bernstein quietly enters the story.
It didn't arrive with fireworks or dramatic headlines.
For years, it hid inside old survey data, unnoticed.
When astronomers finally saw it, the scale changed everything. Bernardinelli-Bernstein isn't just large for a comet. It's enormous. Roughly 137 kilometers across. Bigger than many cities. Bigger than any comet we've measured. But size alone isn't what startled scientists. What mattered was how it woke up. Normally, comets stay frozen and silent, far from the sun. Only closer in does sunlight bring them to life.
There's an expected boundary where activity begins.
Bernardinelli-Bernstein crossed that boundary without hesitation. More than 16 astronomical units, it released carbon monoxide gas. That's far beyond Saturn, where sunlight is incredibly weak.
At those temperatures, most comets should still be asleep.
Yet this one wasn't.
Imagine finding a campfire burning on a frozen mountain.
That's how unexpected this activity really was.
Carbon monoxide is a super volatile, active at extreme cold.
Its presence suggests an interior preserved since solar system birth. This comet is ancient, untouched, and remarkably intact. Now comes the deeper question. Are objects like this rare? Or were we simply unable to see them before? History and astronomy often reflect technology, not reality.
Massive objects drifting slowly don't announce themselves.
They barely reflect light and leave no obvious trails.
The was found because we learned to look differently. That raises an uncomfortable possibility. What if this isn't a one-time discovery?
What if it's the first we happen to notice?
The outer solar system may hide countless dormant giants.
Ancient icebergs parked in the deep freeze of space.
May awaken unpredictably, just like this one.
That forces us to rethink how comets behave. This isn't about Earth being in danger. But it changes how we see our solar system.
The solar system is messier than tidy textbooks suggest.
It's dynamic, layered, and still full of surprises.
We're not just tracking stray snowballs anymore.
We may be witnessing a hidden population reveal itself. Objects capable of rewriting formation theories.
Objects preserving clues about ancient materials and gases. They hint at how water and volatiles spread long ago.
So the real question isn't about danger.
It's about what else is out there, unseen. And how long it's been waiting for us to notice.
Bernardinelli-Bernstein didn't change the solar system.
It changed our perspective. Sometimes, that's the most important discovery.
Science advances when assumptions quietly break. And this comet cracked one wide open.
It reminds us how little of space we truly know.
And how much still lies beyond our detection. We are finally learning how to see the invisible. With better tools, more discoveries will follow. Each one will challenge what we think we understand. The outer solar system is not quiet. It's slowly revealing its hidden giants. Bernardinelli-Bernstein is just the beginning. A reminder that space still holds deep mysteries.
And we are only just learning how to listen.
When strange objects from space make headlines, the story usually feels familiar.
Recently, that role was played by an object called 3I/Atlas.
Against the infinite darkness.
For many, it felt like a warning shot from the universe.
But scientifically, 3I/Atlas was never the main event.
It was more like a scout than the real story.
A signal that reminded us space isn't sealed or quiet.
Physically, it was small and limited in what it could reveal.
Meanwhile, something far larger was moving quietly in the background.
Something was Bernardinelli-Bernstein.
At first glance, it looks like just another distant comet.
No dramatic tale, no sudden brightness, no spectacle.
It was discovered by looking backward, not forward. Scientists found it hiding inside years of old survey data. That alone reveals how limited our vision once was.
Because when something this big goes unnoticed, blind spots matter.
Bernardinelli-Bernstein is enormous by any comet standard. About 137 kilometers across. But size here isn't about fear, it's about memory.
In space, size often determines what an object can remember.
Imagine 2 ice cubes left in a freezer for years.
The small one changes quickly, cracking and fading.
The massive block barely notices the door opening.
Bernardinelli-Bernstein is that massive block.
Size insulates its interior from heat.
Delicate gases remain trapped deep inside. Materials preserved since the solar system was forming.
Smaller comets lost these ingredients long ago.
What we see today is often just their weathered shells.
Bernardinelli-Bernstein is different, closer to untouched.
It acts like a deep freeze vault of cosmic history.
This is where the contrast with 3I/Atlas matters.
Three I/Atlas was exciting because of where it came from.
But it tells us little about our own solar system's past.
Bernardinelli-Bernstein tells a deeper local story. It comes from the distant Oort Cloud. A region once thought to be quiet storage. This comet suggests it's anything but static.
It became active far earlier than expected.
Challenges older ideas about comet behavior.
It shows large bodies can stay rich and intact for billions of years.
And they can awaken quietly, long before we expect.
That raises an unavoidable question. If one object like this exists, how many others do?
We didn't see it because it didn't announce itself. Large, cold bodies move slowly and reflect little light.
They don't grow dramatic tails until very late.
Bernardinelli-Bernstein may not be unique.
It may simply be hard to detect.
Once that sinks in, the question changes.
We're no longer asking if such giants exist.
We're asking how many we've missed.
That realization reshapes our view of the outer solar system. Its mass, structure, and evolution may be incomplete.
Not wrong, just unfinished.
This isn't a threat to Earth.
The comet will never come close to our planet. The real impact is how it changes perspective.
Three Isla/Atlas reminded us, space is open.
Bernardinelli-Bernstein reminds us, space is ancient and full of things we're only learning to see.
One grabbed attention.
Rewrites understanding.
In science, that's the discovery that lasts. It doesn't end a story. It opens a better question.
What else is waiting, unnoticed, beyond our reach?
How much history is still frozen out there? And how many answers are still sleeping in the cold?
For decades, we imagined the Oort cloud as a frozen warehouse at the solar system's edge.
A quiet place where comets sleep, untouched, for millions of years.
It was a simple, comforting idea, and probably incomplete. What if that distant region isn't static at all?
What if the Oort cloud is a slow, evolving ecosystem?
From far away, stillness can hide long-term change. Imagine standing on Mars, where nothing seems to move at first glance.
Beneath that calm, forces reshape the surface over ages.
The Oort cloud may behave the same way.
Slow collisions can happen without dramatic explosions.
Tidal stress quietly stretches orbits over millions of years.
galactic gravity tugs constantly, even from far away.
These changes are too slow for human intuition. Our models often smooth out these subtle effects. That smoothing may hide important dynamics.
Objects like Bernardinelli-Bernstein hint at this deeper story.
One clue lies in its unusual orbit.
This comet travels on a path almost perpendicular to the planets.
Nearly 95 degrees of tilt is extreme.
Planets orbit flat because they formed from a spinning disk. So when something breaks that pattern, we notice.
Orbits like this rarely come from calm histories.
Something disturbed this object long ago.
One suspect is the galactic tide itself. As the sun orbits the galaxy, gravity slowly reshapes distant paths.
Another possibility is a passing star from the ancient past. Even a distant flyby can leave lasting effects.
Think of ripples spreading across a quiet pond.
Objects far away can still be nudged into new directions.
Bernardinelli-Bernstein carries the signature of that disturbance. Its path records a history written over millions of years.
This wasn't a smooth, uneventful journey.
And that raises a larger implication.
If one object shows this, others likely do too. The Oort cloud contains trillions of bodies.
Rare events become inevitable, given enough time. Over millions of years, disturbances accumulate.
The outer solar system may be quietly active.
But this is not a story about danger. Bernardinelli-Bernstein poses no threat to our planet.
Most Oort cloud objects never come close to the sun.
The real challenge here is understanding. Our mental picture of the solar system may be outdated.
We once divided it into active and frozen regions.
Evidence now blurs that boundary. A dynamic Oort cloud changes how we model the system.
It affects estimates of mass and long-term stability.
It reshapes expectations about how often objects move inward.
Each new discovery becomes part of a larger pattern. Not anomalies, but clues.
Early weather models once missed atmospheric chaos.
The system was always complex. We just couldn't see it. The Oort cloud may be similar. Quiet does not mean lifeless. Cold does not mean inactive.
The frontier lies not in distance, but in understanding.
Our tools are finally catching up to the questions. Better data reveals motion where we saw stillness.
Each improvement sharpens the picture.
The outer solar system is still largely unmapped in behavior. That uncertainty isn't a weakness. It's an opportunity. We are watching a shift in perspective. From frozen boundary to evolving frontier. Bernardinelli-Bernstein is one messenger of that shift. It reminds us how much remains unseen.
And how patient the universe can be.
The Oort cloud may be quiet, but it is not asleep.
And we are only beginning to understand its story. When people hear planetary defense, they imagine sudden danger and ticking clocks.
That power appears. Alarms sound, and the count begins.
That image feels familiar, dramatic, and reassuringly short-term.
But objects like Bernardinelli-Bernstein don't play by those rules.
They don't rush in. They arrive on timelines measured in ages.
This comet isn't dangerous, but it is deeply instructive. It forces planetary defense to rethink what warning time really means.
Long-period objects begin their journeys incredibly far away.
They drift inward from regions we rarely observe directly.
By the time we detect them, they're already committed to their paths.
There's no rewind button for gravity.
That's very different from near-Earth asteroids we track repeatedly. Those objects give us years, even decades, to prepare.
Long-period visitors usually give us just one encounter. Bernardinelli-Bernstein reveals that blind spot clearly. Not because it threatens Earth,
but because it challenges assumptions.
The uncertainty isn't about speed, it's about distance.
And distance hides risk in quiet ways.
Now, this realization changes how scientists think about preparedness.
But it also changes how discoveries themselves are made.
The new era of astronomy isn't led by bigger mirrors alone.
It's driven by data, stored patiently over many years.
Bernardinelli-Bernstein was found by looking backward in time. Old survey images revealed something no one noticed before.
That wasn't luck. It was a change in method.
Instruments like ALMA can sense faint molecular whispers. Wide-field surveys quietly record the sky night after night.
Artificial intelligence connects dots humans never could.
Slow movers, faint signals, long stories unfolding. Even decade-old data can hold new discoveries.
Bernardinelli-Bernstein proves the outer solar system hasn't changed. Our ability to see it has.
And that brings us to a rare moment in science.
We're alive at exactly the right time.
Too early, and none of this would be visible.
Too late, and these discoveries would feel routine.
We have enough tools to detect distant giants.
Enough knowledge to ask the right questions.
And enough mystery to stay curious.
That balance is rare in science. It's when understanding accelerates fastest. Bernardinelli-Bernstein doesn't signal danger. It signals opportunity. A chance to rethink long-term cosmic risk. Chance to improve how early we truly detect threats.
And a chance to understand our solar system's edges.
This isn't a finished map we're studying.
It's a living system, still revealing itself.
Long-term hazards aren't loud or fast.
They're subtle, distant, and easy to overlook.
Data is what brings them into focus.
Each discovery refines our questions.
Not fewer questions, but better ones. Science doesn't erase mystery. It reshapes it into something deeper.
Bernardinelli-Bernstein emerged from the dark quietly.
Not to threaten us, but to teach us.
It reminds us how much remains unseen.
And how patient discovery can be.
Planetary defense now looks farther than ever before.
Astronomy now listens to archives as much as skies.
The frontier isn't just out there, it's in information.
We're not near the end of the story.
We're near the moment. It becomes clearer.
Clarity brings responsibility and wonder together.
Bernardinelli-Bernstein marks that turning point.
A reminder that knowledge grows quietly over time.
And that science works best when curiosity stays alive.